Ever get that feeling, like, when you're scrolling online and it's like, wait a minute, how did they know? I was just thinking about that.
Yeah, like you were shopping for, I don't know, a new coffee maker, and suddenly, boom, coffee maker ads everywhere you look.
Exactly. It's a little spooky, but also kind of cool. Like, it feels personalized in a way.
It is. It's big data at work. And it's way more than just targeted ads. This stuff powers everything from, like, predicting traffic patterns to, helping doctors diagnose diseases earlier.
Okay, so we're doing a deep dive today on big data. You sent over some really interesting research on this kind of a crash course.
It's fascinating stuff. And it's not just about, bigger spreadsheets. We're talking about data on a scale that's almost impossible to imagine.
All right, so before we go any further, we got to talk about the elephant in the room, or maybe the giant data server in the cloud. What exactly is big data? I mean, we've always had data, right?
Right, but it's the sheer scale of it now. Remember when a gigabyte seemed like a ton of storage?
Oh, totally. Like, back in the day, that was a big deal.
Now we're talking about petabytes, zettabytes.
Yeah.
Scale so massive they make a gigabyte look like a grain of sand.
Okay, those words don't really mean much. Like, give me a comparison I can actually wrap my head around.
Okay, imagine every book in the Library of Congress. Got that picture in your head?
Yeah, tons and tons of books.
Now multiply that by 100. That's about 1 petabyte of data.
My brain officially hurts. Seriously, though, why is this happening now? What's changed?
Well, think about it. Smartphones. Everyone's got one.
True. Always glued to them.
And those things are constantly spitting out data, where you are, what you're looking at, even how you're holding the phone.
It's listening too, isn't it?
Maybe. But even without that, it's a goldmine of data. Then add social media, where people willingly share everything about their lives.
Oh, yeah. Every detail, from their breakfast to, like, what they're thinking about while sitting on the toilet.
Exactly. And we're not just talking about people anymore. The Internet of Things, right? Your fridge can probably order groceries online now.
Mine can't, but I get it. Everything's connected.
Right. So it's not just us. It's sensors, machines, everything's pumping out data nonstop.
So all this data, it's not just like names and addresses neatly organized in a spreadsheet, is it?
Nope, not anymore. A lot of it is unstructured data, messy, complex, and much harder to analyze.
Unstructured, meaning,
Wait.
give me some examples.
Think about a social media post. It could have text, pictures, videos, even location data, all mixed together. Or the sensor readings from your fitness tracker. It's not as simple as rows and columns anymore.
Okay, I'm starting to see the problem here. We've got this tidal wave of data, most of which doesn't fit into our neat little boxes. That sounds like a recipe for disaster.
It definitely presents some challenges, and that's where the concept of the 5 V's of big data comes in. It helps us understand what makes big data so different and what we need to do to tame it.
All right, hit me with those 5 V's. What makes big data so different from, well, just plain old data?
Okay, so the 5 V's of big data: volume, velocity, variety, veracity, and value.
We've definitely covered volume, but what about these other V words? What do they mean?
Well, velocity is about speed.
Okay, so how fast it's coming at us.
Yeah, like how fast is this data being generated? And more importantly, how fast do we need to process it to actually make sense of it and do something with it?
So it's like trying to read a book while riding a roller coaster.
Kind of, except the book is being written in a million different languages.
Okay, so that's variety. We already talked about how a lot of this data is unstructured.
Exactly. It's not just numbers and spreadsheets anymore. It's text messages, it's sensor data, it's cat videos on YouTube.
Don't forget about those.
We're talking about a massive jumble of information.
Okay, so we've got this fire hose of data. It's coming at us fast, and it's a mix of everything under the sun.
And that brings us to veracity.
Veracity meaning.
How reliable is all this data? Can we trust it? With so much information coming from so many different places, it's tough to make sure it's all accurate.
Right, because you can have a ton of data, but if it's all garbage.
Exactly. Garbage in, garbage out.
So how do we make sure we're using the good stuff?
That's where value comes in.
Okay, so this is about making sure all this data actually means something, right?
Yeah. We can collect all the data in the world, but if we can't analyze it, find the patterns, if we can't extract insights from it, it's useless.
It's like having a million puzzle pieces, but no picture to put it all together.
Exactly. The real power of big data is its potential, right? The potential to help us understand complex systems, to make better decisions.
Maybe even predict the future, right?
Exactly. But unlocking that value requires a whole new set of tools.
So what are these tools?
Yeah.
Because our old way of handling data spreadsheets, databases, It's not going to cut it anymore, is it?
No, not.
The document you shared mentioned distributed computing. What is that?
Imagine you're trying to bake a cake, but your oven is like the size of a thimble.
That's a tiny oven.
You'd never get the whole cake baked at once, right?
Right.
So you need to divide the batter up, bake it in smaller batches, and then put it all together at the end.
So distributed computing is like having a bunch of little ovens working together to bake one giant cake.
Exactly. We're talking about massive networks of computers all working together to process these huge data sets.
Okay, that makes sense. But where are all these computers? Do I need to build a data center in my basement?
That's where cloud computing comes in. It's like renting space in someone else's data center. They provide the hardware, the infrastructure.
So I don't need to become a computer expert to use big data.
Not at all. The cloud makes it accessible to anyone.
That's good news. But we still need somewhere to store all this data, right? What about databases? Can our old databases handle this?
That's another big change. We're seeing a shift towards what are called NoSQL databases.
NoSQL. Does that mean NoSQL at all? Because I thought SQL was kind of important for databases.
It's a little confusing, I know. NoSQL actually stands for not only SQL, it's not about getting rid of SQL entirely, but about having more options, more flexibility.
Flexibility for all that messy, unstructured data we talked about.
Exactly. NoSQL databases can handle different types of data, and they can scale up more easily to handle these massive data sets.
So it's like the difference between, I don't know, a filing cabinet and one of those giant storage bins you can get at the hardware store.
Perfect analogy. Sometimes you need something a little more flexible.
Okay, this is all starting to come together now. We've got the 5 V's that define big data, new tools like distributed computing, and NoSQL databases.
We're building a whole new infrastructure to handle this data deluge.
But it's one thing to talk about the technology. I want to talk about how this actually affects people in the real world. What are the use cases here? The document you sent mentioned a bunch, but one that really jumped out at me was healthcare. I mean, big data in healthcare. That sounds like something straight out of Star Trek.
It's healthcare.
That's the one I was really curious about. I mean, using big data to improve healthcare, it sounds amazing, but also kind of like out there,
It is pretty amazing. We're talking about potentially revolutionizing the way we diagnose, treat, and even prevent diseases.
Okay, so how does it actually work? Give me the breakdown.
So imagine taking all the health data we have, electronic health records, clinical trials, genomic data, even the information from those fitness trackers we talked about.
That's a lot of data.
It is, and it's only getting bigger. But the thing is, when you start combining all that information, you start to see patterns that you would never have noticed before.
Patterns like what?
Well, for example, researchers are using big data to identify people who might be at higher risk for certain diseases based on their genetic makeup, their lifestyle, their environment.
So you could find out you're predisposed to something like heart disease or diabetes even before you have any symptoms.
Exactly. And that early detection can be life-saving. It means you can start making changes earlier, get screened more frequently, maybe even start treatment before the disease has a chance to take hold.
Wow. That's incredible. We're talking about like predicting the future of your health.
In a way, yes. But it's not just about prediction. Big data can also help us personalize treatments, develop new drugs, and even prevent outbreaks of infectious diseases.
Okay, so this all sounds amazing, but I have to ask, what about the risks? I mean, we're talking about people's health here. Sensitive information.
You're right, it's not without risks. Data security is a huge concern.
Because if someone hacks into a hospital's database, that's bad news.
Exactly. We need to make sure these systems are secure, that patient data is anonymized and encrypted, and that there are strict regulations in place to protect privacy.
And what about bias? We talked about how algorithms can be biased, and with something like healthcare, that seems especially dangerous.
It's a valid concern. If the data we use to train these algorithms is biased, then the algorithms themselves will be biased, and that could lead to unfair or even harmful treatment decisions.
So we need to make sure we're using diverse data sets, that we're constantly checking for bias and correcting for it.
Absolutely. Transparency is key here. We need to be able to understand how these algorithms are making decisions and make sure they're fair and equitable for everyone.
Okay, so it's not just about the technology, it's about how we use it.
Exactly. Big data has the potential to transform healthcare for the better, but we need to be thoughtful, we need to be responsible, and we need to have these important conversations about ethics and equity.
It's a lot to consider, but this has been a fascinating deep dive.
It really has.
To wrap things up, if our listeners take away just one thing from this conversation about big data, what should it be?
I think the biggest takeaway is that big data is more than just a technology. It's a force that's shaping our world in profound ways. It's up to all of us to understand it, to engage with it, and to make sure we're using it for good.
Couldn't have said it better myself. Well, that's all the time we have for today's deep dive into the world of big data. As always, thanks for listening and stay curious.